All right, I'm going to start on the one-sheeter review here. All right, 2 letters are selected at random from the word ideas. What's the probability of selecting 2 vowels? Now again, I have some options here on how I could decide I wanted to tackle this, but here's the way I would probably look at it. I'm like, okay, I got 2 letters I'm working with here. So how many vowels are in the word ideas?
Trace.
1, 2, 3. So out of how many total letters?
5.
5. So my first blank, or my first one, I'd have a 3 out of 5 chance at getting a vowel. So let's say I'd have taken the word ideas and I cut it up and I put it in a hat. So I pull an I out the first time. Well, I still have that. How many vowels are left in the hat right now? 2. And how many cards or letters are left in there? 4. Because I already took 1 out of there. So at this point, since I'm doing probability, I'm just going to end up multiplying straight across. And I always want to reduce when we're doing something like this. So that's how that would come. Now, could I do that with combinations and all that fancy business? Sure. But again, we've always been saying we like to try and keep it as simple as possible. Just let your common sense take over on something like that. Usually makes it a little bit easier. Good start. Where else do we need to head? Number 7. Now, number 7 seems to me an awful lot like number 3. 2 letters are selected from the word brakes. It's just different size, and it's still 2 vowels. It's just written a little bit differently. Okay. Yeah, that's the thing I will mention though. When we get to number 8, my shading didn't come through real well, because this should have looked a little more like this, which probably would have made this a little more sensible, possibly. So the relative frequency histogram here shows the distribution of the number of tails when 2 coins are tossed. Find the probability of getting 2 tails. Okay. Again, I could choose to do it several ways, but since it's here, 2 tails. Okay, oops, I guess I could just circle it here, 1/4. Because I took it directly from 2 tails, probability, my little graph went up to here, which is the equivalent of 1/4. You know, could I have done it with combinations? Sure. Could have sat there and did, well, the probability of getting 2 tails is 1/2 on the first, 1/2 on the second, and just multiply them together. That would work. 2 if I didn't have a table. Where else are we heading? Two dice are rolled on number 9. What's the probability that both will roll a 5? Okay. So again, when you throw 1 die, does it have any effect on the other one?
Unless I hit it.
Not really. So what's the probability each time that I'm going to get a 5? Okay. 1 out of 6. And then just multiply those together. Yeah, the biggest thing with these is trying to think if it's independent probability or if it's conditional. Rolling a die is different than drawing 2 cards from a deck, because once you take the first one out, now it just changed your probability. With dice, each one has their own independent result. Well, let's see. Number 11, when rolling a die, what's the probability of rolling a 5, there's the magic word, or a number greater than 3? So yeah, this is an addition one. Because when you see or, with either thing being able to happen, I'd have to put those probabilities together. So what's the probability of rolling a 5, 1 out of 6, a number greater than 3, there's 3 of those, and I'm going to leave that as 3 out of 6 because remember, when I'm adding and subtracting, it's nice to have a common denominator. And then is there any overlap between rolling a 5 and rolling a number greater than 3?
5, 6.
Okay, so I have to take that one back out because I don't want repeat customers.
So it's just 3, 6.
Yep, so 1 plus 3 is 4 minus 1 is 3 6, which of course reduces to 1/2. Absolutely. 10, let's see. A bag of jelly beans contains 5 red, 7 green, and 4 blue jelly beans. What is the probability that 2 green jelly beans are chosen without replacement? And that does matter. So let's see, how many total jelly beans are in our bag? Close. How many total jelly beans are in the bag to start?
16. Seven plus 4 is 11, plus 5 is 16.
Plus 2 is 18. So,
Where'd you get the 2? That's, they're asking how many 2.
oh! 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 Ah. Can I look later and go, Hardy, what are you doing? Not reading carefully. That's what Hardy's doing. 16 total. Thank you for those of you that repeated that for me a couple of times before it clicked for me. So 16 total. So I've got 16. And what's the probability of getting a green one the first time?
116. Oh, wait.
Okay. I was going to say, now I'm not crazy this time. 7 out of 16. So then now, I take that green jelly bean and I eat it. So, how many green ones are left now?
6 out of 15.
6 out of 15. And I believe that's going to reduce. That's funny. I'm already making bloopers on Monday to put on here. What else? What else? What else?
For 13, what is it? Any of the PS never has to be that.
Right. If you're doing 13, basically what you'd want to do is I probably ahead of time would have made myself some little tree diagrams just so I could see
There's 4.
There's 4.
yeah, there's 4 people.
Oh, okay.
Yep. And what I basically do is the first time I just take the first person in the list, combine it with the other 3, because I can't combine them with myself. And then here I go, okay, well, Jenna's already been comboed with Rhonda, but I could still combo her with Brian and Aaron. And then finally, when I get to here, I could have Brian, but I've already comboed him with Jenna and Rhonda. So we'll squeeze Aaron here and on the edge. So I notice that there's 1, 2, 3, 4, 5, 6 possible ways I can put these together. So then when it says something like team with Aaron, I just go through at the end of my branches and see how often Aaron shows up, which is 3 times out of the 6 possibilities. So there's a probability of 1/2 that you're going to, if you randomly pick a team of 2, that one of the teams is going to have Aaron on them. But having the tree diagram on that definitely is something that's helpful. Where else? So far, so good. Ten on the multi-pager. All right. switch reviews here for a moment. All right. Art. The letters A, R, and T are written on 3 different pieces of paper. The pieces of paper are then put in a bag and mixed up. Logan picks each letter without looking and places them side by side. What is the probability that the letters spell art? So let's see here. For any possible combination that you have here, okay, I've got 3 letters. So if I put them in a bag and I can't see them, what are my possibilities of getting any of the 3 letters on my first draw? Okay, I have 3. I might get A, I might get R, I might get T. But depending on what I get, that's going to be out. So when I get to the next one, I'm only going to have 2. And when I finally get to the end, I'm only going to have 1. So that's where, and again, when it talks about probability, because it doesn't say how many options are there, basically what you'd say is there's going to be 6 total possibilities, but only one of them would have those in that particular arrangement, is what would end up happening on that one. Because you could almost do this if you wanted to, the one that we just got done with the people and putting them into groups. I could do the same thing with the possibilities on these letters. You'd be able to look and you'd be able to say, now, here's the difference though. Because some of you may say, well, if I do that, okay, so I start with A, and then I'm like, okay, well, if I start with A, I might start with A, I might start with R, I might start with T. I don't know. Because then I might have R, or I might have T. I might have A, or I might have T. I might have A, or I might have R. And you're saying, well, you know, how are you telling me? Because then some of you may say, well, wait a minute. A, R, and R, A, aren't they the same letters? True, but do they spell different things? Yeah. Okay. Because otherwise we could say art and rat and tar were all the exact same thing. And they're not. Okay? But then some of you may take it a step further and say, well, but, okay, so here's 6 possibilities, but you've still got that last letter, so why aren't you going to make more, and why wouldn't it be like 12 or something? But how many choices do I have after each of these? 1. Okay? So I still would only end up, and I know all of these aren't even words, but no matter which branches I went off of, I still am only going to end up with 6 options total. And out of those 6 options total, only one of them has art in that particular order. So again, drawing a picture, if that makes more sense to you to visually see it, do that. Otherwise, you can just say, well, there's 3, and then there's 2, and then there's 1 option. There's only 6 options, and art's going to be one of them. Either one works. Sure. So if we go, and we're kind of even looking back at some of these, because these will show back up again. So let's say, for instance, actually I'm going to jump down to 5, because that's one I know we hadn't talked about in here on Friday. Weather records for the first week of May in the last 10 years show that it rained on 14 out of 70 days. Based on this data, what's the experimental? And experimental means I'm not just going with the odds. I actually looked at what actually happened of rain during the first week of May. Well, on 14 out of the possible 70 days, it had rained. And that would be actual experimental. So then I could go ahead and I'd reduce that, and I'd see that, well, there's about a 1 in 5 chance, going by the experiment, that this would occur. Now again, if you were doing something that was more theoretical, which again is hard with the weather because the weather doesn't just do one thing or the other. If you're thinking about it theoretically, either it rains or it doesn't rain. So you may say, well, that seems like a 50-50 proposition. There's only 2 chances. So theoretically, you might say it's 35 out of 70, but there's certain things like weather and things like that, or elections, that you really can't do that with because you can't make the assumption it's going to be 50-50 every time. So experimental would be a much better. So theoretically, here on 6, if there's slots 1 through 36, that'd be 36 spots. And that'd be 37, and that'd be 38 total possibilities. If there's 38 total possibilities, there's only 1 spot on the wheel that's numbered 7. So theoretically or mathematically, my chances would be 1 out of 38 if there's 38 slots and I'm looking for one of them. But now if you found out later that there was like a magnet number 3 and it draws the ball that way this many times, that would change things a little bit. I personally on number 4 would be saying yes. Because theoretically, how many times, if this is my spinner, how many times should it be coming up on 3 and 60 spins? So there's 60 spins, and there's 5 digits. Theoretically, it should only be coming up 12 times. But it popped up 42 times.
But that doesn't mean it's wrong with the spinners.
No, but you could argue that seems awfully strange.
Yeah, but
for 4. Now, if it was like 15 times out of 60, you know, okay.
It doesn't say that. It says, could you conclude something was wrong? You can't really conclude that because it could be a person's error.
It could.
You can't conclude it.
I don't think you could get a definitive conclusion on anything, but you could make the. You could theorize that that could possibly be occurring. I just mainly wanted to get the part in that there's something theoretical going on with it. What else on the probability front? Any of the 3? Anybody? Any? On 16 on the single sheet. All right, nice on this one. Actually gave you the tree diagram to get started with here. So let's see what we got here. Represent the data in the tree diagram. Okay, so we've got a junior group of which there's 8 and a senior group of which there's 13. And then it looks like we break it down further into male and female. So I can do that. So I got females, I got males for each. Now, I'm going to put numbers with this. So let's see. There's 5 junior females, and there's 6 senior females. So, by process of elimination, how many junior males do I have? 3. Because they got to add up to 8, because I know there's 8 total juniors. How many senior males do I have? 7. That could come in mighty handy when I go looking for this. Because I'm like, okay, I have 21 total people. Let's see if that comes into play here. So my probability of getting a senior or a female, there's that word again, or, means we're going to be doing some adding. My probability of getting a senior would be 13 out of 21, plus my probability of getting a female, 5 and 6 would be 11 out of 21. But how many senior females do I have? 6, so I have to take them back out. So 24 minus 6 is 18 out of 21, which reduces to 6 out of 7. So for every 7 times I would pick somebody at random, 6 times I would get a senior or a female. And then that's the same way that it works all the way down. But I do want to mention letter D. The probability of getting a junior or a senior. Think about that for a minute.
Is it 1?
It is.
Bang.
Because juniors, there's 8 out of 21. And seniors, there's 13 out of 21. And of course, I don't have any overlap because you can't be a junior and a senior at the same time.
Whoa.
So when I pick, I'm going to get a junior or a senior. It's going to happen. So it's 1 out of 1. Every time I pick one, it's going to be successful. Yes, ma'am. Okay. Okay, say that one more time. Yeah, whenever it talks about females in general, yep, any female that you have total is going to get included there because the ones that are senior females I end up taking out at the end.
How did you get 74%?
Well, let's find out. All right. At Harlem, an athletic poll is taken. As it turns out, 36 students say they would like to take band and 52 say they would like to take choir. Only 14 say they would like to take both band and choir. Assume all students want to take at least one of those classes. Find the number of students who only want to take choir. Then find the total number of students that were polled.
That's not athletic, though. Yeah, that's not athletic. I can see.
So, I've got band, I've got choir. Okay, so I know 14 want to do both. They would get included, though, within the circle of that particular subject. So here's my band and my choir. Okay, is over here. So if I know 36 total want to take band, 14 of them are doing both. So how many do I have left for just taking band? 22. Okay, and then the same deal going here with choir. I've got 52 total want to take choir, but 14 are doing both. 38.
88.
So I look at this and I go, okay, so let's see here. Let's see if Hardy's done something funny, which is always a distinct possibility. Only take choir. Yep, he's forgotten how to add. That's always a good thing. Well, no, it's not always a good thing, but because as we've said before, you are supposed to add up the numbers that are inside of your Venn diagram. So 36 and 38, last I checked, would be 74. Now, how could some crazy person, who will remain nameless, have gotten an answer like 88? What did they do incorrectly? Right, they allowed those 14 students that are doing both to get counted twice. Because you'll notice if you just took, well, I'm taking my band plus my choir. 36 and 52 is 88. Well, that's true, but those 14 that are doing both, if you wanted to do it that way, you could. But then you need to subtract that number that's in between. So good catch, good catch.
And then, how did you get 15 out of 22 for 21?
All right, 21.
21?
I mean,
Yeah.
so let's bump up here a little bit.
Because I got 15 out of 22.
All right, let's see. Probability of male given that they're overweight. So, how many males are overweight?
45.
45. How many total people are overweight?
66.
66.
Oh, I see.
And then it's just reducing the fraction.
I'm at 5% on 20.
So the important thing with this, especially if they're nice enough to give you a chart that kind of separates everything, always get that given part boxed in, or you're staring just at it first before you start doing your work. Okay, so 23. Now this one's a little different again because we have the magic word in the middle. Or. So my probability of being overweight or female. Okay, so overweight. How many overweight people are there in this survey? 66. How many total people are in the survey? 112. Because it's my total of totals here. So plus, how many females are in the chart? 50 out of 112. But how many are female and overweight?
21 over 66.
Okay, right. Female overweight is 21 out of our total. So 116 minus 21 is 95 over 112. That word or means everything. It means you get two separate things going, and that's going to give you a little bit better of odds of having just both things. So this would be different than just being overweight given it's a female.
Why is 25 from teacher?
Okay, so let's see. 25. In a class of 36 students, how many ways can you choose 4 students to be on a committee? Again, here's my way of looking at that.
Order math. I can't have the same person be all 4 people.
Well, right, I'm thinking I got 4 places on this committee of mine, and I have 36 kids. So now comes the argument, well, after we get to the mathematical part here. How many people can just run into that first slot on my committee? 36. Okay, then how many are to the next spot?
35. 34. 33.
Now, here comes the argument, though. Because if I sit and I say, okay, let's discuss 36 times 35 times 34 times 33.
Yup.
So you're like, okay, let me move the calculator over here a little bit. Hence, the argument would stand, is this a permutation or a combination? Does order matter? Because if I kind of started to play with the calculator and I said, okay, I've got 36, order matters, I'm picking 4. Okay, I got the same thing. But if I say 36,
Combination. Pick 4.
order doesn't matter, that's a pretty big change. So I guess the question we need to go back and discuss then is, does it matter?
Yes.
So if I have Amy and Priscilla and Ben and Maddie on a committee, notice it doesn't say anything about president, vice president, anything. Does it matter which order I put them in, or is it the same no matter which order I write them down in?
It's the same.
If it's the same thing, which one of those 2 numbers needs to be used?
L smaller. Is it the big one? It's not.
This is good. You guys have found 2 out of 3 so far. You're like, what do you mean? I've got 3 wrong answers up there. You found 2 of them.
That's the line.
Now,
There's 3 wrong
there's 3.
I think that's
Because see, I'll be honest. I'll even put this on my YouTube page. I've got some of you, I think, some of you, not all, some of you have been jotting down, I have a feeling, answers in a lot of this, because there's not a lot of work to show. And I didn't want to find out when it came to the tests, so I'm like, okay, if I throw a few bad ones in here, let's see what happens. So like I said, you found 2 out of 3.
Well, I'm doing good.
Well, I'm not, I haven't looked yet.
Well, that's good.
I can't read the answers.
But here, order does not.
So with number 24, would that just be a combination?
You have 6 CDs. How many ways can you place them on a shelf?
Would that be 6 times 4, 6 times 5 times 4? No, would that be 6 times 6 times 6?
Well, now let's see. Somebody pop in with their 2 cents worth here. 24. I know. I'm going to have somebody else.
Times 4 times 3 times 2 times 4.
Okay. If you have
You
6.
can only put 1 on the shelf and you only have 5 left.
Okay, I got 30 CDs. I should know. I actually got over 100 by the time.
So if I have 6 CDs, I'm being told
I got 4.
okay. Because when you think about it, if you were going to look later, it would make a difference on if you had this particular CD here, if you had it here, or if you had it here, if you had it here, and so on and so forth. So yeah, I agree. That would be a 6 times 5 times 4 times 3 times 2 times 1.
Okay, on 15 for the odds, don't you need the little dots?
You can write, good question. When you're doing odds, you can write it as a fraction, or you can write it with the ratio dots. Normally, I write it with the ratio dots just because it reminds me that it's odds instead of probability. Yeah, and the thing, again, that can get interesting here is there's a couple of things. If the probability of an event happening is 6 out of 11, the probability of it not happening would be the rest. So 5 out of every 11 times it doesn't happen. Because what are the odds not happening? So remember, odds is success over failure. My successes in this case would be it not happening, which would be 5. But then how many times is it successful? Yeah, because that would be failure in this case. Oh, that's really interesting to play with. If there's 11 total events and 5 of them are successes, it leaves 6 for failures. Or I can also write it that way. Either one of those will work for me. 26.
Thank you. I was just working on that one. When they're on there.
All right. The odds of a player making a free throw are 2 to 1. Okay? So this means 2 successes for every 1 failure. So in other words, that means this person's going to make 2 out of every 3 free throws because they're going to have 2 successes and 1 failure for every 3. If he shoots 27 free throws, how many of them will he make? Well, if I just figured out from this information that he makes 2 for every 3 he attempts, and he's going to shoot 27 or attempt 27, how many is he going to make? So, yep, 3x is 54. So it looks like he's going to make 18. So you're taking the odds application and actually, to me, turning it back into probability. And this would be, again, theoretical. He may make 20 in a row. We don't know. He may miss 20 in a row. Ugh. What's that?
What is mine?
For which one?
Forever 2.
Oh, back to number 2. Single sheeter?
Yeah. I'm trying to find your other mistake.
Okay. I am going to give a survey to high school students about how I'm doing as a teacher. I plan on only giving the survey to students who have A's. Is this appropriate?
No.
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 So is that why it's like
Yes.
Give it to yourself.
Why is it biased, though?
Because he's only surveying students who are doing well in his class.
I'm on that list. Number 7.
Right?
Right. So that's actually one where we can say, but now if the question also was to say, how could I make this non-biased? How could I make this experiment non-biased?
Ask everybody.
Ask everybody, okay?
And ask your peers.
Oh, well, peers, that can get interesting, but. Okay, and now I already forgot what the next question is. 7. 2 letters are selected from the word breaks. What's the probability of getting 2 vowels? All right, let's see here.
Didn't I ask for no?
Yeah. So I got 2. I got 6 letters total. Then once I get the first one, so if I draw A, I only have 1 vowel left. And there's 1, 2, 3, 4, 5 letters. And now desperately people are trying to figure out what other goofy thing I've done. But it's not that one.
Ooh. Then it's definitely number. I don't even know which one. Which one is this on the board?
Can we do 27?
Sure. All right, back to the back. To the end. 27. When building my laptop for college, I can choose from 4 different screen sizes, 6 different hard drive sizes, and the case color can be black, silver, or alien green, which would be 3 options. How many distinct order matters computers can you create? All I'm going to do is multiply those guys together. That's it. Sometimes they do seem too simple. Biggest thing you can do for yourself, though, is make sure that you just go over some of these things to be thinking about it a little in the morning before coming in. If you're still having issues, pop in on me, even if it's a couple minutes early in the morning, just to go over a couple of things. But reminder, homework stuff for this, the reviews, are due by tomorrow. So if you want the extra credit on the big one, tomorrow. The single sheet here, tomorrow.